And good morning everybody, welcome to another edition of What the Hell is Going On in John Ox's Brain. Nobody knows, it's a mystery. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So good morning to everybody. I saw earlier someone, who was it? I think it was Chip, was talking about much caffeine infusion occurring here, which reminded me, I have coffee. No, let me clarify. I don't have coffee for myself. Hang on, dropping the audio level. I don't have coffee here for myself to drink right now. It's better than that. The coffee factory next door has started doing pods. So they're putting their freshly ground coffee into pods. And because they're closed on Sundays, normally when there are barbecues on, we can't do the super nice coffee. But now I can, because the coffee machine is here and I have some pods from the coffee factory next door. So if you turn up today to the barbecue and you're feeling cold and decaffeinated, I can encaffeinate you. So, who have we got here this morning? So Chip is in the chat. Unfortunately, after a big trip yesterday, Chip and Immy aren't going to be able to make it in person, but still here in the chat. DIY in the ghetto, Keith H. I think Keith is coming today. Michael, some call it fun. Stephen W. David Howes is here. Michael, Peter is here. Yes, Peter, we are there yet. Are we there yet? We are. Gerald, Stephen, The Lane, Amanda, Mad Techie, Cassio, Cable Tie, Sharky, Paul, Ray. Stephen says, John branching out into the drug supply business. Only the legal stimulant business. Jack's Tech is here. Now I just heard a notification beep. Where are we? Okay. I was trying to load the chat thing that Mitchell did, and it doesn't seem to be loading at the moment. Mitchell can't make it to the stream today, so I don't have my tech support person on hand to figure out what's going on with it. But it should be working. So hang on, I'm just going to try reloading. No. What happens if I go back to it? Is it going to want to authenticate? No, I'm authenticated. It's just not loading. It says loading audio and never actually gets anywhere. So unfortunately we have no chat to speech today unless Mitchell happens to jump on. Henrik, yes, I saw you sent me some stuff on Discord. We might get to that, but I don't know. Keith H is trying to use the chat to speech thing and it didn't work. Sorry, Keith. I've tried loading it and it doesn't want to run. Yeah, it doesn't get to the point where it loads the audio thingy for Chrome, so we can't do that today. All right, now updates. I'm going to show you something that I did. I know that I was going to do all of the OpenKO stuff on stream, but I ended up, when was it? I can't even remember what day it was. It might have been after the stream last week. I went ahead and routed the PCB. So let's start with a quick look at that. I haven't gone back and looked at it since. It was one of those situations. So doing PCB routing for me goes through several different stages. Probably the most effort is the part placement. It's jiggering things around so that when it comes time to do the routing itself is actually very quick and easy. And then, sorry, I'm just waiting for Fusion to load. And then the actual turning air wires into traces is pretty straightforward. So, and then the second stage is that it's clicking through, putting all the traces down. And then the third stage is when I sit there and stare at it and think, can I optimize that? Can I make that track more direct? Can I swap these and that'll save me a couple of wires? So where are we? I'm just looking through. Super open KO, here we go, opening up. I will bring this up on stream in just a jiffy. But I didn't want to actually send it off for fabrication until going through it, because all through this process I've had really good feedback from everybody in the chat, which has been very valuable. And the schematic is could still do a little bit of cleaning up and things. So, oh, it says copyright 2022. All right, let's have a look at where this is up to. So schematic-wise, it hasn't changed much since what you saw, because I think we had the schematic reasonably well sorted in the last stream, but there is that to fix. So let's fix that copyright date. Come on, give me the info tool. 2023. And what is the date today? No, it's 14th. 14th. 0914. What? Oh, 2022. I was wondering why the date. I was looking at this and wondering about why this is on the 14th when we're on the 10th today. It's because this project started so long ago. Let's make that 2023 0910. And this sheet is still a bit of a mess. You can see that, oh yeah, I stuck a display in there. That might have been after, yeah, that, in fact, I don't think I've even finished routing that. I've got to remember where I got up to with this. Okay, so the schematic needs a bit of neatening up around there, and this part is probably okay. The regulators are in place. So let's look at the PCB. Did I... Oh no, I did route that. Okay. Yeah, so I thought what might be useful is to put a little I2C display in here just for a status. I don't know if it's actually going to be useful, but I put it in anyway. Let's see if we just get rid of those air wires. Yeah, everything is routed, nothing to do. So what the board actually looks like is what you can see down there, but I do also have a 3D model of it. So this, I think this might be just about the most recent. I think it was pushed to the 3D model fairly recently. Now why is my Space Mouse not working? Got to unplug and replug. There we go. Unplug and replug the receiver dongle. Can I make all of this smaller? Make this bigger? Yep. Okay. So this is where it's currently up to. We've got power supply down around the bottom leftish region, CAN bus connection there. This is the connection to the KO serial port. We've got the two downstream USB connections. There's the USB hub sitting right there. ESP32 up the top. What did I go for? Did I go for an S3? I have a feeling that I did. Looks like it, just based on the number of connections across the bottom there, which means we don't have a USB to serial converter, we've just got a USB-C connection. And you can see there's a little I2C OLED sitting on top, up on a header, so that if this is all in an enclosure, this can be just inside the faceplate of the enclosure. It's a tiny little display. It's only a 128 by 32 display, so the resolution is very small and it's monochrome, but it could be useful just to show certain things, like maybe the latest G code that it sent, or I don't know, something. Whether the machine has been initialized, whether it's been homed, the current XY coordinates or something. Yeah, so that's basically it. Oh yeah, we've got CAN termination on there on a jumper. There's a, what is that? That's a MOV, I think. So that's some protection on the power, on the USB connection. That's the CAN termination resistor, the big one there. I think it's a 2010 footprint. There is a TVS, so there's a transient voltage suppressor on the CAN bus. There's the CAN transceiver going into the ESP32, which has a built-in CAN controller, so it doesn't need one. So that's made in Australia. I should move that somewhere. So that's kind of where it's up to. All right. Oh, Johnny's here as well. Okay. Gerald says, I see Australia uses the date in the correct order too. I don't know about Australia. Well, Australia definitely does not do month, day, year, because that's just stupid. But most people do day, month, year. And I use, but I don't like that. I use year, month, day because it's going from least resolution to highest resolution, and it is unambiguous. One of the problems is if I had done this as something like 10th of the 9th, 2023, Americans would read that backwards because neither of these digits is over 12 and it's ambiguous. So they would look at that and go, oh yeah, that is 10th of August, or is it 9th of September? I don't know. You just don't know. But by putting the year first, it disambiguates because it forces you to, that it is not either day, month, year or month, year, day. It can't possibly be either of those. So this is much less ambiguous. And it also means that if you do a sort, like in a file system, it comes out correctly because even if you do like a naive ASCII-based character sort that doesn't understand dates, it will still sort it correctly. Hang on, Jack's Tech says Americans will still read it year, day, month. Why? Why? That doesn't make any sense. Yeah, okay. Oh, hang on, Michael says year, month, day, please. Year, month, day. Yes, that's it. That is correct. All right. I'm going to scroll back. Hang on. Okay, I needed to hit the cough button. Right. Paul says, "G'day from Adelaide." G'day, Adelaide. Yeah, that's how far back I've just scrolled in the chat. Peter just said, I just saw a comment from Peter referring back to Amanda. Amanda said, "Good morning from Toronto Hospital." What? You came out of hospital just recently, I think, didn't you? Like 2 weeks ago? And you're back in there again. Sorry to hear that. That really sucks. I hope you're doing okay. But I'm glad you made it along to the stream. And hopefully we can distract you or something from whatever is going on. Andrew Cochran made it as well. Good morning. Gavin is here. Peter said, "Steve and Steph, proof of life, please." All right. Okay. It's been a while. It has been a while. So here is Steve. Where's Steph? Steph is up hiding behind my cap. And there is Steph. And there is Steve. And there is Steph. Maybe there's only one squirrel here, and you never actually see them both in the same place at the same time. No, there are two. Where are we? Scott's comment. Yeah, this is pretty much it. When you're doing the final bits, the final tweaks on PCB layout, 86 hours of nudging things 0.01 millimeter at a time. Yeah. So Stephen asked, is the KO expecting TTL or RS232? It is expecting TTL. And at the moment I'm driving it. So where are we? Which sheet do we need to be on? CAN bus interface, KO interface. Yeah, so you can drive a KO very, very simply. So what we've got here is the receive, which goes to the transmit of the KO, and the transmit line on the microcontroller that goes to the receive of the KO, and a ground connection. This is a 3-pin pluggable screw terminal. That is the matching connection that is on the KO as it comes from the factory. It's a 3.81 millimeter pitch screw terminal, which looks, where are we? Come back here. Is it this one? Yeah, it looks like that. And that is exactly how I'm driving it right now. I have a rack 32 running an ESP32 on it, and all I've done is connected into the I/O header with the second serial port, and I am just connecting directly to it. There is zero circuitry required. It's a direct connection. All you need is a ground reference and the transmit and receive pins connected to the little lead that comes out of the KO. And then you can talk to it at, from memory, 115,200 bits per second. And as long as you can speak their 8-byte protocol, then you can control it. So the interface, that's the thing, is this whole board could have been a terminal, like a connector on a shield to plug into like an ESP32 based dev board. What I'm doing here is total overkill. It's ridiculous. It's gone so far beyond the minimum viable thing. So my original idea was I will just get something like a Lowland 32 light and put a shield on it with a connector, and I'm done. I'd have a nice little neat USB interface. I could run my firmware on it and connect it to the board. But this is kind of fun. It's kind of interesting to do something like this, which is massive overkill with a built-in USB hub and extra downstream USB ports, and it's got a CAN bus interface and all the power supply stuff on it so that we can supply power to other devices over the CAN bus or be powered from the CAN bus, and display and piezo. And do I have an RGB LED on there? Because I usually do on my projects. Looks like I don't on this one. Yeah, so this is way more complicated than it needs to be. But it'll do the job and do more than the job. Oh, Johnny says there is an ISO standard, just use that. Yeah, so the ISO standard time, where, I'm going to look up the format, ISO standard time format, I can't remember the number for it. Hour, minutes, seconds, what is the ISO date and time format? Right, this is on whatis.com. Okay, ISO representation for that is, yeah, so this is the format that I use. It's the ISO standard for the date. Which can be done without the dashes, but it's always year, month, day. This, the wrong way. This is how dates should be represented. Always. Where? I've lost it now. Either that or that. And I do it with the dashes just to make it a little bit more human readable. Okay. Scott says overkill is best kill. Yes. Oh, Henrik said, I thought as well, add RGB addressable LED and maybe an IR receiver to use remote. Oh, Imi, thanks for that question. I will answer that in a second. But this, feature creep, feature creep. I am fighting the urge. Okay. There is actually a valid reason for doing this. Yeah, Michael says, I don't put extra ideas in his head this late. But it's not... Yeah, Jack's Tech says nerd snipe. Exactly. Celtic Bee says, John's YouTube channel is mostly about over-engineering a simple light switch. 100% true. Now, the thing is, Austin has done light towers, like status displays. What's the term for that? I can never remember it. Oh, Peter is here. Welcome, Peter. Thanks for coming along. And adding some kind of a driver on here for an RGB LED light strip would open up the possibility of controlling a status tower directly from this. And that could actually be very interesting. Whew. Now there is a light tower in the... Yeah, Jack's Tech says we just call them traffic light towers. Or Andrew says stack light. Yeah, and I think there are other terms for them as well. I'm pretty sure that I've seen some other term. I don't know where it came from. I don't remember where I've seen it. Oh, Johnny says you haven't seen my 555 featherboard, Peter. All right, I am going over and over in my head here. What you are seeing, witnessing in real time, is me spinning in my brain about whether to add a stack light interface to this, and if I did, what form it would take. Because the thing is, the pick and place machines already have lights on them. I wonder if this is going to work. I don't know if it will. I haven't done this for a while. I'm going to try going portable with my phone Droid Cam, and I don't know what. Oh, Scott says never add IR remote. Yeah, I wasn't thinking of it as being like mood lighting sort of stuff. I was thinking of it more as if there is an interface for controlling a lighting system from this controller, it can be used for a status display, like there is an error in comms and make the light flash red or something. So, okay, Droid Cam is running. I don't know if this is going to work. So, hang on, I'm going to try pressing this. Is it? No, it's not. Okay. Oh, hang on. What have we got? Camera 8 is... This is coming in on camera 8. How is that working? I'm just going to switch this. Okay. I think we're mobile. So backing up from my desk and moving around here. So that is looking into the cleanish room. And let's go and have a quick look at... I know it's going to be very jerky. I'm going to try to walk smoothly. Woo, lights go red. See, it shows the door seal status. See the lights around the that far door. If I open this door, the room seal is broken. The lights go red. I'll close the door behind me. Status goes green again. All right, the room is sealed. So, looking at the pick and place machine, if I come around the back here, you can see it's got a stack light on here. This is driven by the onboard motion controller that is inside the pick and place machine. And it's actually not really that useful in its current form because I've got no direct control over it. It flashes green with each successful command that it receives, but I can never really make it go red or do anything useful. So just coming around here, this is the connection that goes to the stack light, and it's a 4-way 3.81 millimeter pluggable terminal block. So my guess is that it's very simple. It's just like common anode and then 3 switched cathodes, or vice versa. It'll be something like that, really basic. I doubt it'll be like an addressable thing. And coming over to the third machine, you can see the stack light sitting on here. So if I investigate that connection, I can probably make something that is the equivalent of this connection and then drive the existing stack light, or I could use a replacement. I kind of like the idea of using a replacement and not having, so I think this is just like 3 big switched LEDs, individually switched. I haven't ever taken this apart to see what's going on with it. Maybe that can be the thing to do today. What do I need? I need a socket to get that, no, like a hex driver to get that off, and then I can unscrew the top. Maybe I can just unscrew the top right where it is. All right, so I'm going to need, oh, can't really see where I'm going because I'm looking at the camera. I'm going to need a screwdriver. I'm just going to take the top off it. Oh, there is everybody. Yes, in seasickness mode for a moment. I'm going to take the top off this one. Oh, you can see the big mess of setup down there. So a lot of this, see that big cable mess? That is the point of making this custom controller board, is to eliminate most of that. So I don't need the USB hub and a whole lot of, oh, in fact, I can show you this now. So down there in this mess, there is the rack 32, which is currently running. And see these cables coming off here? That is the communications port for the KO, that cable. So that's what we'll plug into our new controller. And I'm just going to take the top off this stack light in the hope that that is all I need to do to see what's going on with it. Now what's happening in here? Ooh. That's cool. These are just literally piled on top of each other. Neat. All right, so there is a little driver board or something in the bottom, and these are LEDs on flex PCB wrapped around a central core. But they are just regular LEDs. They're not actually colored LEDs. The color is being set by this filter, and that is probably just a driver board, like a that'll be a constant current thing or something like that. That's my guess anyway. So I don't know. Oh, what's down the bottom there? Oh, there's a QC sticker. Oh, there's a piezo buzzer down there. See, it's out of focus. You know, I'll see if I can get the phone to focus. There we go. So see where it says tested? Down that sticker. Oh no, passed. QC passed. 24 volts DC. That's a siren, I'm pretty sure. So this is a combination of a siren and a stack light. Now, what order did it go in? Green was there, and then yellow. Did I just knock that? I don't know. And then red. And there we go, it's sitting down there, and then the cover back on. Do I want to go to the trouble of making a custom stack light? I'm just going to leave that for now. That can stay there. Why can't my phone focus? All right. Shaky, shaky. Back into the office area. Hang on, I need to put Steve and Steph back where they live. Steph normally lives up there. And Steve normally lives up there. Just up behind the headphones and my my O'Reilly cap. All right, switching back to here for now. All right, what has everybody been saying? I just saw Michael says, I think we figured out why it's called a stack light. Yes. Scott said, put them back in reverse, then you can get red to light up. Henrik said, so is it addressed? It only has 4 pins and 4 devices. Ooh, yeah, so maybe the siren goes off when the red one is illuminated. I've never actually seen the red one illuminated, or the yellow as far as I know. Okay, so just scrolling back a little bit in the chat. Gerald says, pink, make it pink. What was this? Peter said, replying to Johnny Bergdahl, if it doesn't have at least 4 liquid hydrogen tanks, I don't want to know. Henrik says, could I use the RGB LED PCB that he sent me? Maybe. That is possible. Yeah, Imi says, the cleanish room looks amazing. Next step is backlighting the entire room so it glows red or green. Yeah, I want to put a whole lot more lighting in there. Just more overhead white lighting. It's good at the moment. The illumination is good, but I want it to be great. I'm not satisfied with good. Good is only part way there. Yeah, I do want to put LED strip under or inside the pick and place machines as well. Make them change color. Got to make it look cool. And Michael says, barbecue attendees, your challenge is to make it go red. Yeah. Peter says that's not cable mess, that's art. All right. So Stephen said, is it constant positives with switch negative or constant negative with switch positive to the lights? I have no idea. Yeah, I'm investigating that right now. Do we want to pull apart a stack light? I don't think we really do. Was it a beeper or a small power supply? It was a beeper, yeah. Red and yellow lights are actually not functioning, says Peter. Maybe. Stephen says, if your retinas remain functional after turning the lights on, there aren't enough. Yeah, put on sunglasses to go into the cleanish room. Jack's Tech says, not unlikely that it's serial. It's possible. It didn't look like there was enough electronics in there, just from what I was seeing. There was it looked like just a voltage regulator board, like a constant current power supply, and not much else. What I saw inside it right then, you know as much as I do. That was the first time I've ever taken it apart to see what was going on inside those lights. Right. Now, where am I going? That's right. Imi asked, was it Imi? Asked a question earlier, which I was going to get back to, which is it's way off this topic, but where was it? It's way off this topic, but it's a social sort of thing. So I thought I'd answer it. I can't find the comment. But it was basically, did I have a good Father's Day last weekend? And the answer is yeah. It was a really good day. My littlest sister came down from Canberra and we all went into the Queen Vic market, which was really cool. I hung out there for a few hours. So it was with my dad, my stepmom, both my sisters, and my nephew, and my son and daughter went in. Well, my daughter was working in there, so we went in and met her. So we hung out at the Queen Vic market for a fair bit of the afternoon. And yeah, it was a beautiful day and really nice. It's fun in there. I like it. Father's Day, yes, Imi, that's right. That was the question. So I had to rush off early after the live stream last week because I had to get to my sister's place, and then we were all going into the market. It was good. It was really good. I got to eat some donuts from the famous donut van at Queen Vic Market, the place that sells it by the bag, and was it bags of 5? I think they sell. So okay, we were there. So a bag of 5 donuts was, yeah, it's like one of those old time camper trailer things, but a really big one. And this particular donut van has been at the Queen Vic market since sometime, I think in the 1970s, and it's been doing business. It's basically like a local institution. It's a place that has been selling donuts for 50 years or something like that. And there is always a big queue for it, but the queue moves really fast. And so my sister and I, when we were there, we went and grabbed donuts for the group. Hang on, got a cough again. And so, but the queue moves really fast. And the thing is, there are no options. It's not like you can walk up and say, I'll have 2 donuts, please, or 1 donut, please. No, they sell them by the bag. There are 5 per bag. It's $10 per bag. That's it. The only thing you can say is how many bags you want. And it is so fast. So they've got people in the truck just making the donuts super, super quickly and bagging them, and they're going straight out. So they're in your hand like 30 seconds after they've been made, and the queue is just constantly moving. So we were sitting there, well, we were in the queue, and it was moving, and I was watching the time, and people would go up and say, 1 bag, $10, 2 bags, $20, 1 bag, $10, and they just kept handing them out. And I figured that they were making, on average, like they were bringing in on average somewhere around $30 to $40 per minute. So that is allowing for someone, the next person, to walk to the counter, say, I'd like a bag, please. They grab a bag, here is the card, wait for the transaction to go through, all good, step aside, next person. And it would take like that long for a $10 or a $20 sale. So they were making probably $40 per minute out of this van. Cinnamon? No, just sugar. Like big round jam donuts, so jam-filled donuts with sugar on them. Really fluffy and fresh and really nice. And $40 a minute. So yeah, we were talking about it afterwards, and my stepmother, who's been going to that market, I think since the 1970s, and the van was there then. Oh yeah, so Jack's Tech says jelly donuts for the American. Okay, so they call jam jelly? All right, so jelly donuts. It's a jam donut. And yeah, that trailer was there selling donuts in the 70s. And it's still there selling donuts. And so she was talking about how when they bought that trailer and set it up in the first place, or when they first got it started at the market, it was probably a big investment. And now, all these years later, it has paid for itself many, many times over. Okay. I think I need a drink. Jackstack says, truly an institution, that place. So do you know it, Jax? Or are you just talking in general terms? Henrik says, look back at my comment. All right, scrolling back. What did Henrik say? Henrik said, usually they're interacted with the e-stop. Yes. Jackstack says, okay, missed that. Although it could be on the other side of the board. Right, yeah, so there could be a serial interface on the bottom of that control board. It is possible, but I don't think so. My guess is to keep it really simple. What they're doing is simply switching 3 lines, and I bet that the buzzer is connected to the red one, the e-stop, the alert. Yeah, these machines are nice. They're really nicely made in terms of everything fits well, everything runs smoothly, it's quick. It's got powerful servo motors. The position is nicely repeatable. But most things about it are reasonably simple. They haven't overcomplicated anything. So the communication with the controller is a classic example. That 3-pin screw terminal, and it's just TTL level serial, 115,200 bits per second, ground reference, and that's all you need. The whole machine is designed like that. Everything is simple and logical, not overcomplicated. So they could have a serial communications protocol between the motion controller and the stack light, but I don't think they do. I think what they've done is they've simply bought off-the-shelf stack lights that have a basic like common anode connection and with 3 inputs, and they've just got 3 switched open collector grounds or whatever. So yeah, well, Henrik said, I mean, if you push the e-stop, the red LED should light up, or maybe the yellow. Yeah, the e-stop button, there are 2 e-stop buttons. There is the big red one that just kills power to the whole machine, and that also kills power. So that kills everything. It means the stack light won't illuminate, the motion controller is dead, everything is dead. So all the power to the machine runs through that big red e-stop button on the front. And if you mash that, the whole machine is off. Then there is also a stop button on, there are 3 buttons on the front of it. And one of them is servo. And I think what that does is disable the motion. I haven't ever actually used them. What are the others? I can't remember. But it is possible that that is the, yes, that is connected to the stack light in some way. Jackstack says, having said that, it's a safety system, so you're probably right. Dry contacts that the KO controller juices. Yeah, that's right. Okay, Paul says, red might flash with a buzzer and then an acknowledgement silence button to turn off buzzer and stop the flashing. Henrik asked if I could test them now. That is kind of tempting. Let's go, where's my phone? Do we still have, if I switch this back to, all right, here we go. I am going to switch this, and you're about to see my hand. There we go. So I just switched the input. And we'll go for a little walk back in here, seasickness mode activated again. I need a portable camera with a gimbal or something on it, and one that does a much better frame rate. The frame rate is partly what the issue is here. So I'll just close this machine. And this is what we're talking about. Servo, start, pause, reset, emergency stop. Now I'm going to rotate that. Now if I move the machine around, in fact I'm going to do that. So before I start messing with the emergency stuff, I'm going to show you what happens if I drive the machine. So I'm just going to launch OpenPNP, and then I'm going to connect to the machine, and yep, it's connected. I'm going to move this out of the way and open this so that we can watch inside. And then I'm going to click the home button and you'll just see the sequence of what happens. So clicking it now, it's now running the conveyor to clear it. And I'll move over here. You can see the stack light is on green. And then each time the motion controller gets a different command, the green flashes, I think. So it received a command telling it to home, and it has cleared the conveyor, but that was only one command, and then it does a whole bunch of things. It clears the conveyor and makes sure there is a little sensor down on the output down here. It makes sure that there is no board in it, and then it closes the conveyor until it hits the limit switch, which zeroes its position, and it also homes the head down here, which has now been homed. So it received a single command which then caused the stack light to change state. So it's gone green. Now if I home it again, let's see what happens. I think it's going to turn off. Yeah, see? So that has now turned off. So what happens is that the green alternates its state with each command that's received. So the result is that when the machine is running a job, that green light is just flashing each time it receives a command, which might be like a command to move the nozzle location or rotate or whatever. Each individual command makes that flash. Okay, so now I'm going to close that. I'm going to rotate that to get it out of the way. Let's see if I can get all of this in the picture. To get this, I've got to get down on my knees to get the right angle. All right, now there is a servo button here. If I press that, nothing happens. All right, what happens if I press start pause? Nope. I think that these buttons are reported back on the serial connection to the host computer as inputs to the control software. But I've never actually investigated what's going on with that. What I should do is run the sniffer on the serial thing. All right, I'm going to press reset. Reset does nothing either. So I don't think these buttons do anything directly to the motion controller. I think that these go back to the control software and they can be used as inputs to change its behavior. And the emergency stop just kills all the power. So I'm going to, if I hit that now, look at that, the machine is dead. All the lights are off. Nothing is powered. So that is like a master. And now it flashed red. Interesting. When I started it then, it flashed red, but there was no buzzer, which means that the buzzer is not connected directly to the red. Okay, time to head back to the chat to see what's going on. Back here. Oh, look, a bit of inception happening there. That's my OBS computer hanging off to the side that does the intro and exit animations and things. Okay, Peter says the buzzer isn't working. Oh, Don, you made it. Cool. Order to make them work. Stephen says, green light off, check all 4 pins with the DMM. Green light on, check all pins with the DMM. Yes. I broke it. Yeah, Scott says, I think it's DJI that makes a rather nice little action cam with built-in servo stabilizer. Yeah. The issue is getting the video live from the camera into the broadcast system so I can integrate it with the stream. So Henrik says, I have an idea. Google it. Yeah, I don't think there's any documentation online for this. Chip says, dysfunctional buttons. Dysfunctional. Non-functional. Functionless. Yeah, something that I do want to do is get the put debugging back on the protocol converter. So my protocol converter code, where is it? Oh, Google the Stacklight model. That's true. Yeah, it's probably a very generic sort of thing that you can buy in a market in Shenzhen or something. I'm just opening Arduino IDE at the moment. But you're right, it is... I know you originally said it as a bit of a joking comment, but let's see. Machine stack light. In fact, let's try this. I'm going to bring a different view up on the screen in just a second. Stack light. Where? There, that's what I'm looking for. Okay. So it's these sorts of things. They're probably very common in the way they are connected. So let's just look for some generic thing. Let's look at the very first ad and just find out what there is. So they've got different options: 45mm diameter, 24 volt DC, 220 volt steady, blah 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 blah. Okay. Switch inside, fast or steady. Okay. Round or square type. Default square. Yeah. Loud buzzer. It's got a few wires coming out of it. I mean, the internal structure is a little bit different to the one I've got, but not that dissimilar. It's probably fairly simple. All right, power supply, grey, common wires. And then we have power to the different LEDs and to the buzzer. The only thing is that there were only 4 wires on that connector, and it looks like we need, although I wonder if it's the same. I don't actually have the stack light for that middle machine. I've only got the stack lights for the first and third machines. I wonder if the middle one is different, because the thing is, there are differences between these machines. The design, this is one of the things when you're buying from a company like KO, the machine, these 3 machines were all bought within, I think, a 12-month period, but they were placed as separate orders. So Glenn ordered them originally from KO, got them shipped over to Australia. He ordered one, a couple of months later ordered a second one, a few months later ordered a third. So there were 3 machines that were in theory all the same model, and they all came from the same place over a span of some months. The machines are all different in different ways. What they did was, between 2 of these machines, they changed where they located the control computer. So in one of them, all of the cabling exits out of the side of the machine, and the computer would have sat beside the machine. And in another one, the cabling exits internally, and there is a cavity underneath the bottom where the computer would have gone originally. None of them have their original computers in them now, so they've all been changed around. So there are differences like that, and there are the 2 stack lights that I've got here are different. One of them is on a long pedestal and one of them is not. I think they're different manufacturers as well. So it's quite possible that they changed the stack light, and that connector that I was just looking at is not the same as the other 2 machines. Maybe it was only a 2-color connector, or maybe it was only a 2-color one on that middle machine, or maybe it was 3-color but it didn't have a buzzer. I don't know. But yeah, my guess is that it is just a simple switch connection going to each of those. So this is showing a high side, well, it says grey common wires, but it doesn't actually specify if that is common anode or common cathode. Don't know. Let's just try a different one. Let's try this. See if they have any more information about how to connect it. Probably not. It's the same diagram, of course, because that's the way it is. When you go through all these sellers, they're all going to have, they're all sourcing the images from the same place and copying each other's images. Let's find one with an ad that looks a bit different. This one's got a black section on the top of each of the lights. What is that? Let's see if they've got the same wiring diagram as all of the others. 24 volts. Yeah. Mine did say 24 volts on the inside, so that seems to be the common way to do things. But there's no, unless they've got it here. Where's the wiring diagram? Here we go. Power, grey, power. Yeah, it's the same diagram as the others, essentially. But it doesn't say if grey is positive or negative. And this will just be the colour. It won't actually be telling us which. Purple is buzzer. Where's my chat? I've lost the chat. Lost the chat. What are people yelling at me and I'm ignoring? Jack's Tech says, Google the exact part number. Oh, Scott says when Austin finishes his vacation. Austin's on vacation? Oh, is that why he's not in the chat? Yeah, I don't think he was here last week either. Austin's on vacation. That's very nice for Austin. I hope he's having a great time. Don said, almost always common 0 volt. Yeah, that's what these seem to be indicating without specifying it, which I find a little bit strange, but maybe that's just the way it's done in industrial land. So they have a common ground and then they supply 24 volts to each of the inputs to make the different colors. All right. Since we seem to be on stack lights today, why don't I just rip that one off the machine and I'm going to find a tripod. A tripod suitable for sticking the phone on. All right, got a tripod. It's got a phone thing on it. Let's do this so that I can take the camera in there, put it in a fixed position, and then take that stack light off. Bring it back and then we can try connecting to it. All right. Hopefully I got the correct Allen key. All right, this is going to be very seasicky while I get this connected. There we go. All right. And now back into the cleanish room. I'll take off, I'll take off the one that's on this machine. Did I get the right one? Yes, I did. I should also grab myself some tape because the way these enclosures are made, they've got like voids in them with very small access points. So if you want to get cables through, you've got to fish them through, and often there are spots where there'll be like a piece of steel on the inside of the enclosure with a little hole in it, and then another exit hole which is nowhere near it, so you've got to fish the cable through. I don't know how they do it at the factory. Just skill, I suppose. Come on, there we go. But the thing is that there'll be a cable coming up here for the stack light, and if I drop it, oh look, it's got a wiring diagram on the outside. And is there a part number? I can see some kind of a code on there, but I don't know if that's a part number. So if I drop the cable down inside the machine, it may be really, really hard to get it back out again. Yeah, there we go. So yes, it's a 4-pin pluggable screw terminal. Oh, I'm going to balance that there for a moment while I get myself a bit of sticky tape. So I've got some just over here. Who is sending me messages? That was my phone going ding. Hang on. So I'm going to tape this like that. And I'm going to put these over here so that that can't fall back down the hole. And what else do we need? Anything? No, I think we can just take this back out onto the bench and start messing around with it now. Oh, I kicked the tripod. What a mess it is in here. I was going to try to clean up a bit before everybody came, but I did not. All right, overhead camera on. And some focus. Focus. And then I'll switch over to this overhead camera. Focus. Okay. Overhead camera time. There? Did that work? No. There? Yes. That worked. All right. Pull these off. And I'll fire up my bench power supply in a minute so that we can supply 24 volts to this and see what happens. But first, let's see if we can get into here a little bit more. You can see that there are some Phillips head screws in there. If I get those out, I think I can take out this whole assembly and get to the buzzer, and I should be able to see what the connections are coming in from that screw terminal. All right. Now what is going on? Yeah, this PCB is just, oh, this is interesting. So this PCB is aluminium, which will have been done for heat sink reasons. So you can see there's nothing on the back of it. It's a single-sided PCB. It's white on the top, like white silk screen, and it's all single-sided. I'm going to unplug that. Interestingly, there are 5 connections on here and only 4 connections on here. Where is the other connection coming from? What is going on with, what is up with that? Ah, that's interesting. These 2 wires, they have joined together. I didn't even notice that before. Look at this. So this is a 4-way screw terminal. And from the right, we've got brown, green, yellow. And then this one here, it's got 2 wires into the ferrule. In fact, it's even a bigger ferrule in order to fit the wires. So both orange and red go into that same connection. So, oh, look at this. I really think that this is probably a Glenn special. So Glenn is the guy I bought these machines from. Look at this. This is the positive side of that buzzer that's sitting down inside there. So that piezo has been disconnected and had a bit of electrical tape stuck on it. So I think that this, it looks like it would have previously been connected there, although I could be wrong. So this looks like, yeah, and what is that? Could be a voltage regulator, could be a transistor. To me, it looks like a voltage regulator. Yeah, so I think that the buzzer is meant to be in parallel with the red So when the alarm goes, the buzzer also goes. And that's why we only have 4 connections on here. It's because they've ganged up the red connection for the, for the piezo. So which is common? Which is common? Probably the brown one is my guess. And if someone was saying that normally it's so common cathode. Let's just try. What's the worst that can happen? We can let some smoke out, and that always makes things fun. I'm going to zoom that camera back out a little bit because you can't really quite see enough, can you? More like that is about what we want. Now I'll turn on, which one? Lab supply 1, and grab myself some leads with an alligator clip output. Don't know if you can hear the chainsaw. Stuart's over the road getting into something. All right, I'll get, what else will I get? I'll get the plug that this goes into as well. I have an entire container worth of 3.81mm screw terminals because I use these quite a bit on client projects, including these 4-way ones I use as CAN bus connectors quite commonly. So I'll plug that in there just so that we can get this onto it. Now, what have we got? I'm going to set, common on negative, and on my lab power supply, dial up 24 volts, I'm going to limit it to 500 milliamps, just in case I do screw something up. I'll get all of the conductive things out of the way. Try to get this into a spot where you can see it, like there. All right. And I'm going to connect, oops, it fell off. I'm going to connect onto the far one, which is the orange and red. So this should be the top one, I think. So if I turn on the lab supply, these top LEDs should turn on. Let's see. Whoa! Oh, they are red LEDs. I thought it was just relying on the filter. I thought that these were just white LEDs. That's interesting. All right, I'm going to turn that off. In fact, what I'm going to do is I'm going to leave the lab supply turned on, and I'm just going to touch it onto different things. So this is the second one. Ooh, nothing happening when I can contact that one. What about this one? That turned on. I'm confused. That turned on red as well. That turns on red. That turns on red. That does nothing. Maybe that is the common? How is that possible? Okay, that turns on the middle one. Maybe, what? Okay, which is common? Let's figure this out. Where is this? How do we trace this out? So it looks like that's anode and cathode, just based on the markings that are on the this flex PCB. But tracing it through to here, what is going where? What is going where? Actually, I am going to Google for this because there is a marking on here, L3223, and then it looks like just, I can't tell if that's part of another letter or a symbol, but L3223, maybe that is like a standard light tower type thing. L223, what was it? See, my short-term memory is so bad. L3223. L3223. And does that bring up anything useful? Light tower. Nope, it doesn't. Oh well. Nothing useful there. Charlie Plex says Jack's Tech. Yeah. They're all common. Steven says, check what the diode is doing. And sorry, I'm just getting lost in the chat here. Stephen says, I missed a bit, but it looks like a pinout on the base of the light on the other side of the blue-white label. Yes, you are correct. There is a pinout diagram on the actual thing here. So all of these labels are in Chinese, and my Chinese is definitely not good enough to figure that out. Oh, it's common positive. This one actually does have, hang on, I'm going to see if I can get it. Let's zoom this in. Yes, all right. And the focus even works. So this one seems to have a different diagram to the other ones that we saw online. So this has got common positive, and then it's got switched negative. But why is it showing? It's showing 4 switches, not 3. Oh, but one of them will be for the alarm. Yeah, okay. So I think that this hack here, with putting the piezo and the red into the same one, I think that is that's a KO factory hack. What probably happened is they bought the light tower. It came with 5 leads coming out of it, and then they joined 2 of them together so that they've got 4 leads, and they've ganged up the red and the piezo. So that is why the diagram on here, and also this explains why I was so confused earlier that it was only a 4-pin connector. And how can a 4-pin connector be used for a 3-color plus piezo light tower? Okay. Making sense now. Thank you for... Yes, the lane says pays to read. Stephen says positive is brown. Yeah, okay, so that makes sense. Starting with the common on the end and then working across. And in fact, the colors would even match. So we've got green, yellow, and then red, and the orange is probably the piezo. And that matches, those cable colors will match the colors of the LEDs. All right, let's have take 2 on this. Connecting, I'm gonna have to zoom this back out again. Connecting, oops, what did I just do? I hit something on the camera, but I don't know what. Some mode selector. Okay, so now we've got common positive. Get this back in here. Common positive going to brown. Come on. And I'll push that cover down so that it's moderately insulated. Insulated a little bit. My power supply is on. So now this should be red. It's not. What's going on? What? Why is nothing on this working now? If brown is common positive, okay. So I'm going to try red on there. All right. Maybe the diagram is wrong. No, but that doesn't make sense because that should not. Yeah, this is really weird. But it does not seem to match the diagram that's on here. Unless one of these other colors is the common positive. I don't think I can do too much damage to this. So that's red, that's white, and that's green. Okay. That, that's weird. All right, so if I put positive onto the green and then I connect negative onto the brown, I get red. See that? So if we treat that as a common positive, the green wire is a common positive, and then on this one we get green if I apply power to the yellow wire, and if I apply ground to the ganged ones, I get yellow. Odd. Oh, it's all very confusing. All right, I'm going to try connecting this to here. No, nothing happens. So far, the most sensible behavior seems to be if I connect positive to green, and then I can turn on red, green, or yellow at will, but yeah, the yellow one is the one that's ganged up with the piezo, not the red one, and there's a green one there. That's very strange. That's very strange. Okay. Well, I am going to slowly back away from that and come and see what people are saying. So, yeah, Michael says, Stephen said red, yellow, green, orange, and buzzer are the others in that order. Positive is brown. Yeah, that would make total sense. And Michael said, I'm tipping the yellow wire is the yellow light, etc. But that is not what we're seeing. From bottom orange, buzzer, second green, yellow, third. And Henrik said, also, could I solder the piezo back? Jackstech asked, tripped current overload on PSU? No, it was zero current being pulled. So it was just like an open circuit. Stephen George says, voltage says 12 volts. What volts are on the PSU? I've got it set to 24. What does it say on here? Does it say 12? No, I was assuming it was 24 based on two things. Firstly, if we go back to here, firstly, that 24 volts DC it says, and secondly, oh, but the label here says 12 on the outside. You see, this is, yeah, it's got the box ticked for 12. So this is totally confusing. It doesn't make any sense. It's inconsistent. I am inclined to ignore the existing things, but I've got to think back to my goal for this project. So part of the goal for making the OpenKO device is I want to be as close as possible to a drop-in replacement onto an existing KO machine without having to modify the machine too much. At the moment, I do have to replace the bottom camera, which really sucks, but I don't really have a good solution for that at the moment. But I don't want to... If other people are going to be doing this, I don't want them to have to modify large parts of the machine or replace things just to be able to switch to using OpenPNP and using this controller. So it would be preferable if I could interface with the existing light tower, or stack light, I should say. Okay, I've got to try to remember. Call it a stack light. Scott says, what are the colors in these positions on the machine side? I don't think I can see unless I cut off the heat shrink, because I'm pretty sure that those connections are all covered actually in 2 layers of heat shrink. It's got individual heat shrink on each of the wires, and then there is a larger heat shrink that goes over the whole top. Stephen said, set to 12, what happens? Yeah, that's worth trying, just in case there is some kind of over voltage protection. And Peter says, told you we broke it. Yes, maybe I did. Oh, Michael says the tick box is negative. Tick equals not 12 volts. That's possible. Henrik really wants to hear this piezo. Okay, I can make the piezo run even without soldering it back on. I'll just stick power across the piezo. So that, I'll just strip this a little bit. And that's negative there, so because I'm not powering anything up, I'm just going to clamp this straight around the PCB, including onto the back of the PCB, which is all aluminium, but it doesn't matter if I short. Okay, here we go. Let's hear what this piezo is like at 24 volts. Oh, that's loud. I'm going to change that to 12 volts, even though the piezo says 24 volts. Let's try again. Nope. I can see why Glenn disconnected that. That is really annoying. That's ear-piercingly loud. Even at 12 volts, when it says 24 volts on it. Yeah, that's like it's like a siren screamer. It's not just like an alert buzzer. That's like a screamer that you would put in an alarm system. So let's reapply the the electrical tape insulation. Let's not do that again. Do not like. I do not like. Yep. Gerald says that'll wake you up. Yes. All right. Hang on. My drink is almost empty, but I've got to get out what I can. Not nearly enough. Amy says, it will turn the cleanish room into a panic room. Yeah, if I was in there when that buzzer went off, I would be panicking to get out of there, to shut the thing up. I think I'd hit that emergency stop just to make it go quiet. Michael says, Glenn is currently giggling. Yeah. I was a sucker for connecting it back up. Amy says, panic at the clean room. It's a disco clean room. Henrik says, also the PCB link I've sent could show you it in the last moment. Also, so could you use my PCB, RGB PCB then? Maybe. Yeah, Jackstack says, kind of at this point actually forces you to hit the E-stop. Now, if I'm going to support, right, I mean, it's fun looking at this stuff, but I am really unsure about adding support for this, just because it seems like such a weird, screwed up sort of thing. So if I was going to do this, so it's common positive, switch to anode, what I would need is 3 transistors to switch the low sides of those LEDs. I wonder how much current it takes. Let's find out. I'm going to connect it back up again at 12 volts because it says 12 volts on the outside of the thing, and I'm going to just check on my lab power supply what it's drawing at each of the colors, because I want to know if like a simple little N MOSFET or something would do. But my inclination is towards just putting a connector on that could be used for connecting like a WS2813 style thing. So what did we figure out it was before? Green was common positive, wasn't it? I think that was the way it was working. So I'll turn the power supply back on, touch this one, and red turns on. Doesn't turn on very brightly though. And it's pulling so little power that my lab supply is not even registering it. It's registering like 0 milliamps. It's not up to the threshold. I'm going to turn that up to 24 volts. And it starts glowing a little bit more. Now it's pulling about 10 milliamps, which is surprising. I thought it would be a fair bit more than that. But then it is at 24 volts. So maybe not so surprising. All right, so that's red. And now we'll try the yellow one, which is on the yellow. So that is pulling, once again, about 10 milliamps. And try green, and that is pulling, once again, about 10 milliamps. So we could do this just using some simple like 2N7002 MOSFETs. If I stuck 3 of those on the PCB, we could, in theory, switch a common positive stack light. But do I want to do it? Do I want to do it? Yeah, Scott says just give the board an extra I2C output and you can run a stack light from there. Yeah, and Jack's Tech says we'd need to support both common positive and negative. Yes. What is with that? So I'm not against the idea of adding an I2C header here. So maybe, was it Austin? Someone was obsessed with putting quick headers on things. I think it was Austin. Maybe I should put a quick header on here so that at least there's I2C that could be used for talking to something else. David said, I'm in the process of connecting one of these to my Bamboo Labs printer via an ESP8266 and Node-RED. Oh, interesting. Oh, I think I just saw, hang on, Austin has just appeared in my DMs. With pictures of food. What's going on? Austin on holiday. Is this Austin camping? Oh, Austin, you're making me hungry. Except that I'm not allowed to eat corn anymore, which really sucks. Okay. Show the pics. I don't know if Austin will let me show the pics. I won't just do that unless he says that it's all right. I don't even know if he's watching the stream. I just know that he's just DM'd me in Discord. Okay, to show these pics on the stream. People want to see. That's what send back a picture of a quick connector. Yeah. All right. So maybe I should add maybe I should add a quick connector somewhere. Now the thing is that a quick connector is good. It's for I2C, but maybe I'm too tired for a barbecue. I don't know. But not so good for... Oh, Austin said, yep. All right. I am going to bring this up. So it looks like Austin might... Hang on. It looks like Austin might be camping. Can we... can't zoom that in. So there's a steak and some... Looks like some beans... And that is that's some corn in alfoil sitting on a campfire. Oh, that looks yummy. So that is what Austin is presumably eating right now. Yeah, so anyway. All right, is Austin having lunch? Yeah. You use a splitter on the OLED display, it already has an I2C. That's true. So we do already have I2C on here. It's just a matter of adding the extra quick connector. Do quick connectors kind of need to be horizontal though, don't they? Which would mean putting it on the edge of a board, and we don't have anywhere nice to do that. Is there a vertical quick connector? Whatever a quick connector is. So presumably there is a real part number for it, because a quick connector is just a repurposed connector from JST. What is the quick connector's real part number, so that I can look it up? Quick connector, quick connect system from SparkFun. Under the display, yeah, vertical is an option. If there is a vertical style connector, polarized connector, where is it? Yeah, but what I want is the, yeah, it's a 4-pin JST connector. But what 4-pin JST connector? I want to know the part number. See quick microboards. Yeah, 4-pin JST. JST is a company, it's not a model. It's a, cool, thank you Scott. It's a 1mm SH-BM048. So, let's have a look for that. Looks like there aren't great matches. Let's just do JST SH. Oh, there was a BM048. No. JST SH. JST SH, micro 1mm. Yeah, that's the sort of thing we want. Simon says probably an XH. Yeah, I think XH is a bit bigger, like 1.27mm pitch or 1.5mm pitch. So these are 1mm pitch, and I want, how many pins are on it? Is it 4 pins? 4 pin. 5 by micro SH. What I want is the PCB socket. So Core have them as a side entry connector. Locally here in Australia, so Core is just up in Sydney. That'd be a good place to get them from. But do they have a vertical entry equivalent? JST connectors. Let's see, JST connector kit. There's a whole pack of them. JST connector kit. Yeah, XH is 2.5mm pitch, so it's bigger. So I want SH, which is JST, here we go, SH cable. I want a vertical entry. Let's go JST SH and see what Core have. Products, 214 that match. JST PH. SH jumper 6-wire. Oh, vertical. Here we go. That's the 6-wire though. I want the 4-wire vertical. JST SH vertical. I want JST. Let's search on Core for 4-pin and see if they do that. JST vertical 4-pin, 6-pin. I want the 4-pin. Oh, JST 4-pin vertical connector 10-pack quick. Yes, this is it. Okay, this is a 10-pack of. It's the Adafruit equivalent in a vertical. Okay, so that is the thing. Solid plastic with a 4mm by 1, and then we've got the pinout on here. Do I have a footprint for it? Let's find out. Let's find out. But as I sort of half started to say before, this does not necessarily solve the problem of controlling a stack light, because they won't have an I2C interface. What I really want is just like a spare I/O pin going to a connector for a WS28XX type addressable RGB LED strip. So what I want is an LED strip interface on here. Ooh, Scott has given the specific part number or a description. So let's go back to, where are we? Here. All right. Boom. And that. Yes. DigiKey. That thing. All right. So, thanks, Scott. That was very helpful. What am I doing? Oh, that's right. I was going to see if I've got anything in my connectors library. Could be under N04. What have I got? Ooh. Oh, this is the horizontal standard header. Horizontal. Yeah, this is the horizontal version. I wonder if I could stick this somewhere near the edge of the board and make it fit. I'm going to stick it in here for now. Even if I might replace this footprint later. But what do we have in the way of... oh, here we go. 1 is 3.3 volts, 2 is ground. So which way do I want to orient this connector? 1 is 2, yeah, let's do this. I'm going to go stick a ground down here, stick a 3.3 here. Oops, wrong place. Move that. Oh, maybe which way will I orient this? Thinking about how to do this without the traces being totally ugly. I think I'll do this. So numbered from the bottom up. 1 is ground, 2 is 3.3 volts. No, it's the other way around. 1 is 3.3, 2 is ground. 1 is 3.3, 2 is ground. Why? Oh, I must have just had it wrong before. So I do want it oriented like this. 1 is 3.3, 2 is ground. So I'll get rid of that and do that, and bring these ones out. So what am I going to make it 0.05 and the flag style like that. Now which one is which? 3 is SDA. So this one, 3 is SDA, IO3, thank you autocomplete, and IO4 SCL, thank you autocomplete. I've really come to like that feature. Okay, so, wrong one. So now we have a quick connector. It's the wrong style of connector, but still, we have a quick connector. It would be nice to put this somewhere on the edge. Let's push it to 3D and just...
From popsky.com.
No! Alexa, stop. I've got to remember to mute that before I start the stream because it just responds to weird things that I say. I suppose if I'm sitting here talking for 2 hours, then eventually I'm going to say something that is... oh, come on, what am I doing? That's right, I was going to push to 3D. Yes, I'm going to push to 3D and push. And this should update and we'll get the connector. Stephen says, relocate the fuse and diode and put it between the CAN and USB. Ooh, Scott said, horizontal and vertical have opposite pinouts. Ah, that is so confusing. Why the hell does that happen? Why? James says, I'm getting Anchorman vibes. Will John just automatically Google anything we type here? Yeah, probably. Scott says, put the LED controller in the stack light. Alright, so what we would do is have just an I2C interface to the stack light. But why I2C? Why not use... Yeah, so, alright. What's going around in my head here is there are two major approaches to controlling the stack light. We can either have a stack light that is dumb and it doesn't have a controller, it's just like switched common anode or common cathode, whichever, doesn't matter, for LEDs, which is what that one is at the moment. Or it could be based on addressable LED strip, like WS2813 strip, in which case it's just up to the software to decide what color it wants to go, and it could be any color you like. And then all we need is ground, 5 volts, and a data pin with the appropriate level shifting involved. Henrik said, why I2C? Multiple things can control it. Yeah. Stephen says, if you just have I2C, the end user can decide how they control a stack light, or if it's common, positive, common, or addressable. Yeah. Oh, so Stephen suggested, relocate the fuse and diode and put it between the CAN and USB. Yeah, I could do that. There's plenty of room there. And then I could just move USB up a little bit. I could move that. Yes. Yeah, KHT said LED strip seems way easier. I agree. So Henrik is very insistent about sending me stuff in Discord. Okay, Henrik has sent me some links to AliExpress. What is this? I'm going to click this AliExpress link and hopefully it will be something. Bringing it up here. What have we got? Pixhawk, PX4, RGB external LED and USB extension module with protective case, full color I2C LED module. Interesting. So this is an I2C based LED driver. Does this have... so Pixhawk means that it is for typically, so Pixhawk stuff, if you haven't heard that term before, that is for drones like UAVs and things. There are the Pixhawk flight controllers. They're commonly used on sort of mid-range, mid to high-end UAVs. And this would be for doing things like controlling LEDs on a drone from the flight computer. So the flight computer would talk I2C to this controller, which then controls the LEDs. So yes, Henrik, thank you for that link. That is an option. And here is another link. So here's another link that Henrik supplied. A link to mouser.ee. I've never been to mouser.ee. Yeah, accept all cookies. All right. Oh, EE, Estonia, of course. So I'm going to switch to the Australian one and see if this product still exists on the Australian site. It does, hooray. What is this? LED lighting drivers, 4-channel LED backlight driver with I2C. Ah, cool. So it is a, yeah, that is one way to do it. Okay. What's the price on this? Is it ridiculous? $4.17 for a chip. Not totally ridiculous. But it just seems so much simpler to me to put a connector on here for a basic RGB LED strip, because then it can be anything. Yeah. Stephen George says, just realised, yeah, this is an important point. I had thought about this as well. Vertical fuse will get in the way with the screen if you want to put in a case. Might be worth changing the type of fuse whilst moving things around. Yeah. Oh, and Amanda said, I2C allows you to daisy chain many I2C devices just in case you need to add interfaces. Yeah. I'm just not convinced of using I2C to control LEDs. It seems like, given that there are already addressable RGB LEDs, why not just use them instead of having I2C as like an extra layer in the middle? In some situations it might be useful, but in this case we've got plenty of I/O. I can just assign some spare I/O pin as an LED driver and put a connector on there. Alright, let's go back to here. Yes, so this render does not include the fuse inserted into the fuse holder. I wonder if I have a 3D model with the fuse in it. I have a feeling that I do, or maybe it's only for a horizontal model. I've got, where's the fuse? So it'll be here, maybe? Yes, there's the fuse. Okay, so this is the vertical mount spade fuse. It's an automotive style. Let's, just for laughs, come on. Come on, Fusion. I am sending you a command. The command is add part. Why aren't you opening it? What happens if I click there and then click? An error, add. Now it works. Okay, so fuses, fuse. Yeah, so this is the vertical mount one. This is the horizontal mount one. So I'm going to just stick one of those in the schematic, which means it'll end up on the PCB somewhere. But this is a horizontal mount fuse. If I spin this around, I can't remember which way around it goes. I think it's this way, but maybe it's this way. I don't know. We'll see once we get into the render. Okay, I'm going to just stick that there, save it, and then we'll push to 3D so that we can see that fuse in its horizontal format. Yeah, I'd rather not even have the fuse. It just feels like I should probably have one, because there are going to be some moderately high powered things that could be powered through this down the CAN bus connection. But maybe I'm just making things harder for myself. So this is an automotive fuse in a horizontal mount connector. And because it's trying to render it off the edge of the board, you can see that the what would be the plated through holes for that connector are just floating there in space with no fiberglass around them. So that is a mini blade automotive fuse. So that red part is what would be plugged in vertically into this connector here. But that's a horizontal fuse holder. So what I could do is put that in on the edge of the board somewhere and have the fuse accessible from outside the enclosure. that would be good. The more I mess around with this, the further away it seems from being ready. I am inclined to just send off for the board as it is without these extra things, and then iterate on it after discovering whatever problems I have made, because this board is probably not perfect. It's was it Scott said, with the vertical mount, could design the housing so the fuse is changeable without opening the case. Yeah, that's right. I could just have the fuse sticking out of a slot in the front of the enclosure, and you could pull it out and replace it without opening the case. That is also not such a bad thing. That would be kind of workable. I don't mind that. Stephen said the flux capacitor can be added on the next iteration then. Yes, I'm starting to get cold. What can I put on? I'm going to put on this, which might be a bit rustly. I will try not to move too much. Okay, sorry about that sudden noise. Yeah, that's better. 8 minutes, says Stephen. Yeah, I'm going to be stopping pretty much on time because I've got to get things ready for a barbecue. Panic. Okay. Now, quick connector. Yes, the quick connector could go here. That is not a particularly difficult change, and as you can see, there is heaps of room. So maybe let's do that just as a what am I going to do? What am I doing? That's right, moving. I'm going to move this up a bit, move it up to there, and then I'll bring these in closer, and yeah, let's unroute there, and there, and there, and there, so that I can move some things around a bit. Where will it go? We could put it there, and then maybe this will fit in here. I think that'll fit. I think that'll fit nicely. And that can go there. Close enough. All right, let's route this. Or, yeah, I'll bring that up there, bring that up there, bring that into there, and then I've got to rip up that. So I think that's basically it. Oh, apart from routing to the quick connector, of course. Oh, I forgot about that little detail. All right, so I've got to get 3.3 volts in there. We've got 3.3 volts just hanging out on layer 2, I believe. So let's just do that, and that should satisfy the 3.3 volt requirement. Yep, so now we've just got 2 air wires. Just got to cross these over. Let's run, what layer am I on? Route 2. No, I don't want to be on route 2. I want to route on the top layer and bring, oh yeah, that works. Sorry, I'm thinking something and not saying it, but first I'm going to change the grid. Let's go for a 0.5, because I am going to, yeah, you see how this crosses around? That actually works in our favor. Let's bring this, what size is this track? 0.4064, no wonder it looks huge. It's because I was routing that power trace earlier. So let's bring this along and stick it here. Bring this along Oops, too far. Oh well, I can fix. Oh, it doesn't matter. It's not too far. Move that along there. Ooh, got another. I got a DM from Tinker. What is Tinker saying? Ah, Tinker has a footprint. Thank you. There is a footprint for the for the quick connector. So what have we got? SEL, SDA, 3.3 volts. Let's just change width. Come on, 0.254. Just drop that down a bit in size. And are we routed? 0 air wires. Very good. Scott says, you might like the quick connector footprint that I use. Yes, thank you. That does look good. In fact, that footprint, if I'm interpreting that correctly, that is a multi-purpose footprint for both through-hole and surface mount. Is that correct? And Scott says, allows for stacking boards instead of using cables. Oh, so you can put, yeah, okay, so you can do it vertically. Let's see this in 3D again. And just see what the clearances are like around that, around this area. This should update any second now. And let's see what the quick connector is like next to the USB connector. Oh yeah, so Scott says pin header on top and SMT pin socket on the bottom. Right. Yeah, cool. So we've got the CAN connector, quick connector next to it, and USB connector, hopefully with enough room there on either side of the USB connector for it to be plugged in. So there was a very good question from Adverse Effects, which was, why use a big fuse like that? Well, it's actually not that big of a fuse. It just looks big because this board is small. It's a mini automotive blade fuse. So one thing that would be interesting is to know about other styles of fuse. If there is a different style that I can use, I would be very open to switching it to something different. It's I use this because automotive fuses are easy to buy everywhere and they're cheap. They come in different current ratings. I think the smallest you can get is about 5 amps, but still 5 amps. Oh, it says 1 amp on here. So, Adverse Effect says, I'm an ex-motor mech, so I know the fuse you're using. Yeah, they're extremely common. But what would be interesting is some kind of a smaller fuse. I don't know of one though. Is there a smaller, general purpose, easily available fuse? Oh, Henrik says use a polyfuse. Yeah, I don't want to use a polyfuse though. I don't like polyfuses in situations where you're dealing with higher currents and they may repeatedly trip because they degrade over time. Polyfuses, like you can see there, I've got a polyfuse here in the USB connection that is to provide protection for the upstream computer, whatever's plugged into it. But if you repeatedly trip polyfuses, they screw up. They they break down chemically. And with a higher current automotive fuse, they blow, but then it's like 15 cents to just plug a new one in, or 20 cents. So it's not a problem. Paul says one's like in Fluke multimeters. Yeah. Oh, Jack Stack says polyfuses aren't great for motors. Adverse Effect says I sent a link, which is where little fuse visit site. What is this one? Oh, little fuse. That is an interesting thing. So it's a fuse holder. I'm going to have to investigate that. What sort of fuse does that hold? That's really curious. All right. Oh, okay. It's like a pop-out type fuse. That is really interesting. Okay. I would much prefer to use this sort of style if, yeah. All right, I'm going to have to wrap it up because I can't run overtime today. I've got, because people will probably start turning up and I won't be ready. I'll still be sitting here talking. Yeah, so the actual purpose for this fuse, just to recap, this CAN bus connection could be going to other devices on the production line, including to things like inspection conveyors that could be running motors and needing, you know, in the order of an amp or so of power. So higher power devices running at 12 volts, not just, you know, microcontrollers and things. So this could be supplying power to multiple inspection conveyors through that connector. And this fuse is just to protect our power supply if some kind of a downstream device has a short circuit or something stupid like that happens. Yeah. Oh, so Henrik says, it costs a bit, but it's really small and works great if you know right. Yeah. Okay. Yeah. Cool. Yeah, and Adverse Effect says that is the style I linked to. Yep. Henrik says it's double smaller the size of the fuse holder you have now. Yeah, so half this size. All right. I am going to leave that browser thing open and consider dropping it in here on the board in place of this fuse. Because what I'll also have to do is look up the fuses that match that fuse holder. This style. Presumably there will be a range of fuses of different current ratings. Datasheet. Oh, I've got to stop. Now that I'm onto something new, I'm kind of diving into this because it's shiny. Oh, what is the price on these? Unit price, $2. Okay, so it's $2 for a fuse holder. And then how much for a fuse? I don't know. But, okay. Products fuses. Oh, and here we go. Here is the link. All right, I am going to go. Imi says, we'll see you at the next barbecue. Someone's ringing me. Okay, I am going to hit the end button and see who is on the phone. So, thanks for coming along. I will see some of you at the barbecue really, really soon. And have a fantastic week. I've missed the call. All right, I'm gonna hang up now. I'm gonna hang up on the live stream and see you later. Okay, I gotta go. Bye.